All right, ladies and gents, we are coming to the end here. Here is our preview for the final exam. So, as I have already mentioned over on Classroom, there are notes for every unit we have done this semester. If you don't have yours still, you still have an opportunity to get those set and situated so you can have an assistance a little bit on the final. But that's up to you at this point because I'm not going to tell you every part to look for these. You just need to have them. So, let's get down to it. Graph the following lines on the grid provided and determine the solution. All right, graphing lines. This, ladies and gentlemen, is our y-intercept. Y-intercept, -1. Slope. Our slope is rise over run. So we're going to be going up 3 and right 1. And up 3 and right 1. And if we run out of room, instead of up and right, we can go down and left. First one ready. And then we play the same game on the second one. We look and we go, okay, that is a negative in front of the 2, by the way. So +4 for my intercept. We're going to go down 2, right 1. Hey, down 2 and right 1. My hey came from the fact that there is the point they intersect. If you do this right, there will be an intersection point. And that intersection point is at an x value of 1 and a y value of 2. Solve using the substitution method. Hey, that's what y equals is. It goes in the y equals spot. Cool thing about this video, if you think Hardy's going too fast, just pause me. Rewind me. I wouldn't mute me, but hey, whatever works for you. So, a little bit of distributing there. These x's are on the same side of the equals. Do not do opposites when you put them together. And now it's just regular old solve an equation. And again, this video is more made to let you have a visual to see what's going on with some things. This is all stuff we've done so many times. I'm not going to walk it through like we're doing this for the first time. So all I did here was I took my second equation with y equals, and I just took the x and I plugged it in there. So that's where this is coming from. 5. We're good there. Solve by the elimination method. Now, on these, we're always going to check first if I can add straight down and eliminate a variable. Well, -3 plus 5 does not eliminate anything. -6 plus 6 does, though. Those are gone. So -3 plus 5 would be 2x. -9 plus -5 is -14. And just that quick, we have got our first part, but you're not done. Don't put x equals -7 and go on. We still have to take one of our original 2 equations. It does not matter which one. I'm just going to use the bottom one here. And whenever I get to the variable that I solved for, I'm going to plug that in. And what's going to be left, the only other variable is y, and that's what I need to solve for anyway. So we're going to multiply those together. And now do a little first semester 2-step equation solving. Again, cool thing about this, speed me up, slow me down, whatever it is that you're looking for to get yourself set. Now, what if I go to do elimination, though, and I go to add down and nothing cancels out? Well, now I got to start looking around. And I'm like, okay, like me, I happen to notice right away, I'm like, okay, well, 2 and 4. For this to cancel out, what would I have to multiply 2 by to get to 4? 2. But for them to cancel out, they have to be opposite. So how do I make this -4? I multiply by a -2. We are leaving the top alone and multiplying every piece of the bottom one by -2. Goodbye, y's. One step. Got x. Just like we did over here, it doesn't matter which equation you used to plug in to get y now. Let's say, I don't know, let's say I use the top one this time. So I got -1x plus 4y is 9. Negative times negative is +1. Subtract the 1 over. Divide both sides by 4. X, y. Like, dang, Hardy, it's been a while. I know, this is like 5 units ago, some of this stuff. Use elimination to solve. Can I, 6 plus 3 doesn't cancel. No. Okay, well, I got 3. What do I got to multiply 3 by to get 6? 2. Ooh, but 6x plus 6, that's not going to cancel. I want 6 and I want -6. Okay. So similar to what we did in the last one. So that -2 went to all 3 of my terms down below. Whack. Ooh, -20 plus 20, that also whacks. That's kind of interesting. So does 0 equal -14? No. So there's no solution. If that was 0 equals 0, that's true. That'd be many solutions. So just because your variables cancel out doesn't mean you can't finish it. You've still got to see if you end up with a true or false statement to know if you have no solution or some solution. Just saying. Just putting that out there. All right. Determine how many solutions exist in the graph below. No solution would happen when the lines don't cross at all. Well, that's not happening. There's a black line underneath this white one. One solution would be one point where they cross. This is a lot more than that. Cannot be determined, it's just ridiculous. And infinitely many solutions means it's the same line, which is going on here. So that's all we got to do there. All right. Given the following systems, identify which has one solution, which has none, and which has many. I'm more interested in the first part. Okay. I tried to add down. Crap, nothing cancels. What do I got to multiply 2 by to get to 8? 4. We're already in a good positive negative here, though. That's -8. This is going to be +8. So I'm going to copy the first one. The 4 is going to go all the way through. So we'll add down. Okay. Now you're like, okay, so now we got to plug back in. I'm like, wait a minute. All you're doing is identifying which one has one, no, or many solutions. Okay. On no or many solutions, all the variables are going to cancel out. One solution, you actually get an answer for x and y, and I already see that. So this one is going to get a solution, and I know that. And that's all it's asking me, so I'm not doing the rest of it. That's just me. So I get to the next one. If I add down, no, nothing cancels. But 4 times what gets me to 12? 3. So each of those gets multiplied by 3. Leave the second one alone. Whack. back. Okay. Ooh, negative and positive 3. Okay. Here comes one of our other two. Negative 27 plus 21 is negative 6. That's false. Which one's false? That one's false. Good there. Now, do I kind of know what the last one's going to be now? Yes, but I still want to make sure, because maybe I did something else wrong somewhere. So let's see. 3 times what gets me to 6? 2. Top one stays the same. And again, Hardy, how do you know what that number is so quick? Because once I see that adding down right away isn't going to eliminate a variable, I immediately go and say, okay, what can I multiply the smaller number by to get this? 3 times what gets me to 6? 2. That's how I can do that so quick. We add down. X is by, Y is by. Negative 18 plus 18 is there. Oh, there it is. There it is. And I got all 3. Okay, nothing terrible. Nothing terrible. Find the simplest form, no decimal answers. Oh, are these those? Yep. The ones where if I got my notes, I got those nice charts and things. Hardy might be nice. I might give you another multiplication chart in case you missed yours here. Perfect square, 4. Square root of 3. Only the perfect square will get out of radical jail. And that 3 is still hanging out. We're just going to multiply those together. Here, those aren't the same. I cannot just add them up. I wish that was true. That'd be awesome. Again, look in your 63 box on your multiplication chart. If you're there, the biggest perfect square you're going to see is 9. Now, 175 is not on your chart. You're like, okay, Hardy, so what do I do if a number is not on my chart? Here's a couple of hints. You can either, if you have your perfect square list, and you should, you can start dividing your perfect squares into the 175 until we get one, and we will get one, that goes in nicely. Here's the other clue. Here's like the big brain one. You see how that's at 7? That's basically telling you what the other one's going to be. And there's the 25. Now the radicals are the same. I can add the coefficients. But again, the multiplication chart can be my friend. The calculator can be my friend. My notes can be my friend. Because as you can notice as we're doing this review, I'm not putting a ton of note things on here. I'm either assuming you know it or that you're going to be using your notes. So just trying to put that out there. Okay. 5 squared, square root of 3 squared. 5 squared, no radical. Square root of 3 squared. Those cancel. Multiply them together. Here, if numbers are on the outside, we multiply them. If numbers are on the inside, we multiply them. 21, I go looking through my chart, and I'm like, I don't see 4, I don't see 9, I don't see 16. I don't see any numbers that are going to make this any better, Hardy. Okay, well, as far as I go there. Done. If I did have something in there I could do, though, I would. But I can't, so I'm not. The Pythagorean theorem, a squared plus b squared equals c squared. A and b are my legs, c is my hypotenuse. This is c. So when I'm doing this one, a squared plus b squared equals c squared. Let's get a little help. 13 squared plus, oopsie, 16 squared. And square root of 425 is going to be 20.6 longest side. But 13 is a little different. Why is 13 different? Because A and B are always my side. C is my hypotenuse. A and B are my sides, C is my hypotenuse. How do I know which one's the hypotenuse? It's the one that if I start at the right angle and go straight across, that's my hypotenuse. So here, 5 squared plus x squared equals 13 squared. So this time I don't get to add them up because the x squared's on the side with one of my numbers. So we're going to subtract. And when I take my square root, oops, inches, Hardy, not meters, I get my value. So again, kind of working our way through here, seeing how all these things work. Okay, now a little break from all the heavy algebra here. Max or min? Max or min, max. Vertex, let's change colors here. X is 2, y is 4, 2, 4. Y-intercept. Here's the y-axis. Here's where it intercepts. Don't just put 1. The x value there is 0. So 0, 1. Domain, free square. Every time. Every time. Range. Bottom to top. Bottom, negative infinity, to top. Y value at the top. Vertex Y value. There it is. Equation of the axis of symmetry is the x value of your vertex. X equals 2, not just 2. Not just 2. Equation. Got to have an equals in an equation. All right. Find the coordinates for the vertex and the equation of the axis of symmetry in the following. Okay. Remember, when you're doing vertex, that's HK. Why is that important? That's the opposite of H. The opposite of positive 2 is negative 2. That's K. That's K. And just like we said right here, the x value of your vertex is your axis of symmetry. See, when you practice all this stuff, this flows. If you don't, it doesn't. Okay? Describe how the graph are different. Okay, so basically it's asking you what's happening on each of these. Well, the 2 itself is going to stretch my graph. The negative, okay, even if you just said reflect, okay, that's because of the negative. You could even say flip if you wanted to here. Flip over the x-axis. I'll take it. I'll have teachers yell at me, but that's okay. Now down here, this is a little more interesting. You could say stretch. I'm going to use the word compress here. But again, stretch I would take. You're like, Hardy, nothing else is going on. There's not a plus, there's not a minus, there's not anything. The only thing I can think of here would be if I were to graph this. So even with this, you could say it opens down or opens up. You're like, how do I know that? If you don't know that, because of the signs, plug them in your calculator. Opening down. Okay. If I go here, and I graph that, notice it's wider, that's the compressed part, and it opens upward. Okay? Any of those types of things are fine. And we talked about that a lot and have all the words on your notes. Factor completely. Biggest number that goes into 6 and 18. Chart, very helpful here. Very helpful. 6 is the biggest number that goes in. We want the biggest number, the smallest exponent, if all of my terms have variables. So 6x. 6 divided by 6 is 1. I can put a 1 there if I want to. 2 minus 1 is 1. Negative 18 divided by 6 is negative 3. And I already got the x. No more x's. Okay, again, good old chart. Multiplies to get a negative, tells me no, it's one of each sign. That is going to be the sign of the bigger number. So I'm looking again in my chart, and I'm looking for a pair of numbers in the 30 chart that can get me to 7. Looks like 10 and 3 can get me to 7. Positive 10, negative 3. Again, use the chart to help. If you need another chart, I will locate you a chart. Factor and solve, okay, real similar. For an x, 12 divided by 4 is 3. 2 minus 1 is 1. Negative 20 divided by 4 is negative 5, and the x's don't need any more. Set each of those equal to 0. And I am perfectly fine here if you keep it as a fraction, or if you go ahead and, let's see here. I'll take any of those. 5/3, 1.67, 1.7. I'm okay. Similar, again, except we got to solve. One of each sign. Negative number is going to be bigger, so you're back in your chart. Look in the 42, two numbers that are 1 apart, 7 and 6. Does it matter where I put them, Hardy? It does. Sign of the bigger number. 7's bigger. Still rolling. Okay. Maybe we'll take some time during one of these days too, if we want to, and go through the review and kind of chat about, hey, what parts are in what parts of the notes, and kind of start to lock that in. Might not be a bad idea. Okay, perfect squares. How do I know this, Hardy? I got my notes. I'm not even gonna act like there's anything else to it. First term, second term. The minus means it's one of each sign. Set those each equal to 0. Again, fraction, decimal. Hardy's perfectly content. Again, if you went to 0.6, if you left it as a fraction, I'm good. Oh my gosh, we're almost there. All right. Before we can do the square root, can't do it first step. We got to get parentheses by themselves first. Once the parentheses are by themselves, square root of 9 is 3, but remember, this is the step. 2 answers, people. Square root of 9 is 3. Don't just leave it as 9. Got to take the square root. And so now we bust this stinker into 2. X minus 4 is positive 3. X minus 4 is negative 3. Add my 7. I was thinking of the answer already. Add my 4. Add my 4. That was kind of funny. Get to my solution. Solve using the quadratic formula. We've been here, done this, especially lately. ABC, formula's right there. The opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Just that into the calculator. Oh dear. There we go. Ooh, that came out nice. Okay, 20. So we got 28 plus or minus 20 over 4. Time for the breakup. So 28 plus 20 divided by 4. 28 minus 20 divided by 4. 8 divided by 4 is 12. 8 divided by 4 is 2. Let the calculator help, but if you're going to, remember the parentheses. All right, get my little ones in here. We're going to distribute the x through first, adding our exponents. So x to the third is 5x squared plus 14x. And down here, we're going to distribute our 3 through, 3x squared, 15x, 42. And now it's just a big game of combine like terms, starting with the biggest exponent, though. So x to the third is the biggest one. That's the only one I got of that. X squared's negative 5 plus 3 is negative 2. 14 minus 15 is negative 1. And that's the only plain old number. And step by step will get us there. Now, I got to admit, I already did a boo-boo here. Because when it says complete the T-chart, I was supposed to have given you numbers to plug in here. That is on me. So let me do that. The X's should have been in there. So now, you really want to be slick. I could plug those in and do the algebra, but you know what? If I just plug this in the calculator. Now, if I forgot this, I absolutely can substitute that in and get the answers. So this is not the only way, but man, it's the slick, fast way. Oh, bells ringing, all sorts of stuff. Okay. And I look at the chart. Check me out. I'm smart. 2, 2, 3, 1, 4, 2. Then I don't do nothing. That's what I'm talking about. 2, 2, 3, 1, 4, 2. And again, it's not a V. This is not absolute value. It's a U. That's it. That's as straightforward as we can get. Alrighty, are we almost there? Last page. Last page, people. And yes, there will be some multiple choice on the final. Here, little distributing action. 4 times 5 is 20. Add my exponents. It's not those two. 4 times negative 3 is negative 12x. There we go. Express the area. Area is length times width. So 3n minus 5, n plus 6. Little foiling action again here. So we got 3n squared plus 18n. Then the negative 5 goes through, negative 5n, negative 30. I see 3n squareds in a lot of places. Oh, minus 30s. Okay, I actually got to do this one. 18 minus 5 is 13n. 13n, there it is. Rolling. Here, don't get sucked into just distributing the squared. That will not work. It'll be one of the answers, but it doesn't work. It's not right. Do the same thing we just did in the last one. X squared minus 6x minus 6x plus 36. Let's see here. -6 and -6 do not cancel. There we go. And to wrap her up, write an equation. Okay, what's all this, Hardy? This is my A value. 2% is 2 divided by 100, which is 0.02, which is my R. So just plug them in. So I want y equals 15,001 plus 0.02. Okay, be careful. That looks like it, but it's not. The decimal's not in the right place. It's this one. Okay? Again, get the notes off of Classroom if you haven't gotten them. Have this stuff jotted down. Again, options will be coming for the final for you, but man, I think the notes are going to be the way to go on this. But that's your call. We'll see you soon.